Friends, welcome back my channel Siddhanath Nishandar. Please subscribe my channel. Today we start a new topic, introduction to gas turbine and constant pressure gas turbine. Okay, introduction. Okay, first we starts with the classification. We know the gas turbines generally we see the wings of the aeroplanes and where there was one system, then nothing but is the gas turbine. Okay, which is an open type of gas turbine. We further see open cycle gas turbine means what, closed cycle gas turbine means what, where they use, what are the applications. There are only limited applications to aeroplanes. There are lots of applications we see step by step. Starts with the classification, the cycle of operation or path of working substance. Open cycle gas turbine, closed cycle gas turbine, or semi-closed gas turbine. Okay, further we discuss where we prefer open cycle, closed cycle. If you see in the animation, okay, you go through the animation. If we see, I choose a pointer here. If we see here, some of the compressed air, okay, go through that axial flow type of compressor. Further we see here is the combustion, and then finally we see there is a exhaust. Okay, generally they consist of three main parts. There is a compressor, combustion chamber, and the turbine. Okay, if you see this zone is the compressor, if you see as the combustion chamber, and finally is the exhaust. You further see in detail. Today is just we discuss introduction. Okay, this is open cycle gas turbine. For the purpose I prefer this video. In closed cycle gas turbine, the exhaust gas is again recover on the basis of thermodynamic cycle, Breton or Joule cycle, Atkinson cycle, and Ericsson cycle. If we see one derivation in previous chapter, that is thermodynamic air cycle, where we see Breton cycle, where the addition reaction of it takes place at constant pressure. In Atkinson, we know that there is addition of it takes place at constant volume, so it's called as a constant volume gas turbine. We further see in detail. In Ericsson cycle, there is addition rejection is carried out at constant temperature. On the basis of fuel used, liquid fuel, gaseous fuel, and the solid fuels. Okay. Then according to force of heat addition at constant pressure at constant volume. Okay. Okay, by applications I use told that is the aircraft in jet propulsions or propojets. In the stationary, if you see the locomotive link stationary, there again it can be used for the is very important for electricity generation. That is the peak load unit, standby unit, end of transmission line unit, base load unit, or industrial units. Now also they are used the locomotive, marine transport. Further applications I mentioned here for supercharging of IC engine, the ship propulsion, that is marine I told. Industry applications like crude oil pumping, the refrigeration process, electric power generation for the turbojet and turbopropeller engines. Okay, in further lectures we see in details turbojet, turboprop. There's some applications I can mention here. The gas booster pipeline and the reinjection liquefied natural gas plants were also used. We further see this plant actually works. Petrochemical plants, district heating, offshore applications, power generation, and the cogeneration plants. So lots of applications, not limited to marine or not limited to aeroplanes. There are lots of applications we see here. Well, let's start with the constant pressure open cycle gas turbine. Okay, I told that there are three important parts: compressor, combustion chamber, and gas turbine. Okay, if we see some atmospheric air is compressed or sucked by this compressor. Now we know that this type of compressor is which is axial flow type of compressor. Okay, in previous chapter we see different types of compressor. There's one type of compressor, is another is a axial flow compressor. It consists of there is a shaft is mounted with the number of blades. Some of blades are stationary, some of blades are rotary, and the axial air is sucked axially, and the compressor in between or squeezing in between that moving blade and the stationary blade, moving blade and stationary blade. So mostly the gas turbines the prefers the axial flow type compressor. They also use the centrifugal compressor. Okay, atmospheric air is sucked through the filter in the compressor. If you see the symbol of compressor is gradually goes on decreasing. What it indicates? The symbol itself gives the working principle. The suction air, that inlet air going to compress. That means the volume goes on decreasing and pressure is increases. The pressure is increased up to 4 bar. Okay, that compressor air is goes to the CC. Okay, where the combustion of fuel takes place, where fuel is sent externally via burners, and then after there is a gas turbine. Okay, this cycles work on the principle of Breton cycle. Why it is called as Breton? The addition of it takes place at constant pressure. The atmosphere air is drawn into the centrifugal axial flow compressor and compress about 4 bar. Okay, now this compressor is then delivered to the combustion chamber. The combustion chamber consists of, this very important term, see, there is an inner and outer casing. If you see in the animation also, we observe the inner and outer casing. The inner casing acts as a combustion chamber. The fuel enters into the combustion chamber through burners. Okay, the burner injects fuel into the combustion chamber. Okay, now is very important term. Now I discuss the compressed air. Suppose there is 100% of air is supplied to the CC. Okay, out of that only 25% air, if you see here, is this zone, only 25% air is supplied to the CC, and the remaining 75% air is flows over the outer casing. The annular space, inner casing is there and outer casing is there. Only 25% air is utilized for the burning purpose, and the remaining 75% air to cool the CC. Otherwise, because of the some material considerations, the temperature is combustion chamber is going to the 2000 degrees Celsius. Okay, so because of some material considerations, we have to maintain the temperature up to 600 to 800 degrees Celsius possible, because of the combustion chamber is provided with annular casing. The finally gases are exhausted to the atmosphere. Okay, and the combustion gases before exhaust is flows over the turbine, where you developing power, and the turbine and compressor mechanically coupled. If you see here, the turbine and the compressor are mechanically coupled. Okay, we know that is the gas turbine is nothing but, if you define gas turbine, is a rotary type internal combustion engine. As compared with the IC engine is the reciprocating type of internal combustion. Okay, where these are reciprocates. Gas turbine is also one type of engine, but it is a rotary type. If you see here, is a rotary type of engine, whereas the axial flow compressor in the always rotating form, turbines. So it is called as a rotary type internal combustion engine. As compared to IC engine, we see there is a compression, suction, compression, expansion, exhaust is carried out the whole 4 process within a single cylinder. But we see the turbine, the suction compressor is carried out in compressor. Okay, the expansion of the CC carried out in different place, and the after exhaust is carried out different place. So suction and compression is carried out compressor. The addition of heat takes place in CC, and the expansion of gas is carried out in turbine. So the 4 different processes carried out differently in case of is compared with the IC engine. Okay, you see in the IC engine also the very important term. For starting, we use Bendix drive mechanism to start the vehicle. If you start the car or key, there is a starting the motor initially. That is a Bendix drive mechanism which rotates the flywheel before, until the exhaust stroke is not happen. Still the drive is rotated by the flywheel once the exhaust stroke is start, once the expansion stroke is start, the engine rotate its own. There's no need of external prime more. Okay, then bending drive motor is cut off and the IC engine starts is self propeller. Like that, initially to start the compressor we need some external motors to run the compressor. Once the gas turbine runs, there's no need of initial motor. That's amount of power is consumed by the compressor. Okay, if you see, this is very important. Okay, now I told the application where is the in jet propulsion turboprop engines, okay, of the constant pressure open cycle gas turbine. The another application is utilized to produce generate electricity. If you see, the gas turbine is coupled with the alternator, that is main purpose is to produce mechanical power, okay, and that mechanical power is connected to alternator to produce electricity. This is also used in the turboprop engines. Okay, we see there is one plant. That plant is utilized to produce electricity. If you see how it works, there is axial flow compressor, there is a combustion chamber, there is a turbine. After turbine, after expansion of the gases exhaust to the atmosphere. That is the open cycle gas turbine. Okay, for the combustion process is used the natural gas. Okay, that natural gas comes in contact with the high pressure, high temperature air where it burns, and that the combustible products is going to expand in the turbine. Okay, and we produce mechanical power, and that utilized to again generate electricity. Okay, this is the constant pressure cycle gas turbine. In next video we see with the closed cycle gas turbine. Thank you.